start with the first module, VxRail Cluster Architecture and Deployment Options. So what is VxRail? VxRail is a hyper-converged solution from co-engineered uh, between Dell and VMware. So it's basically a list of nodes connected together to form a cluster. That cluster will provide compute, storage for your different workloads. Okay, VxRail is available as a list of nodes. These nodes are available in the form of multiple series. Each one of these series is configured specifically for running one workload. So from the list of the series, we have, for example, the VxRail E series. We have the V series. We have the G series. We have the P series. P series are designed for workloads that require high performance from a compute point of view. The V series are configured with GPUs inside to run VDI workloads. The S series are S is for stands for storage, are servers or nodes, VxRail nodes, designed specifically for running workloads that require a large storage with a limited or with a good performance overall. So these are examples of the VxRail nodes that you can choose from. The good thing about VxRail is that a cluster can have many series composing the same cluster. I can have a mix of E series, V series, etc. in a single cluster. And our software is capable of updating or upgrading the software of all the nodes at the same time without any issues. Okay. In addition to the availability of multiple types of nodes, we also have different types of clusters. That's the reason why I asked in the beginning what type. There was a poll displayed before the session started about what kind of cluster do you have. We basically have 5 types of clusters. Okay, the most used type of cluster is called a standard cluster. We also have other types of clusters. Of course, each one of these clusters is designed for a specific use case. So a standard cluster is a cluster that is made of a minimum of 3 nodes, and this can be expanded to a maximum of 64 nodes. That's what a standard cluster is. And it's actually the most used type of clusters. It has vSAN as the main storage, and it's actually the cluster, the type of cluster, which is covered 100% in this training. So the concepts that we're going to talk about during this training are all applicable to a standard cluster. The reason why I ask in the beginning questions about which cluster do you have, so I can, if we have a customer running a different type of cluster, I can maybe add some additional explanation or notes specific to that type of cluster. You can find everything you want to know about the clusters in this document. This is called the VxRail Network Guide. This is one of the documents I will share with you later, and it's available online. You just need the customer account to access it. So as you can see, this is called the Dell VxRail Network Planning Guide. This version is from August of last year, probably not the most recent version. In this document, you can pretty much find anything you need to know about VxRail networking. But what's interesting here is the VxRail cluster types. This is not part of this training, but I just want to spend maybe a few minutes just to show you the different types of clusters available. We're just going to quickly talk about all of them. So the first one is, as I say, it is called the standard cluster, okay, which is basically a cluster with vSAN. It's made of a couple of nodes connected together, minimum 3 nodes, maximum 64, and we use vSAN. You have the option starting from version 8 to deploy this cluster using either an architecture called OSA, which is the architecture that's going to be covered in this training, or now with version 8, you can deploy it using an architecture called ESA, Express Storage Architecture, which leads me to this simple question. Is there any one of you guys running ESA, Express Storage Architecture? No one. Okay, perfect. The reason why I'm asking, again, this training is based on OSA. Since it's based on version 7.0.372, there was no ESA back in the days. ESA has seen the light starting from version 8. Okay. All right. So luckily, no one is running it. So it's completely different from OSA that we will cover during this training. So this is a standard cluster. Next, we have something called dynamic cluster, dynamic nodes. Dynamic nodes are actually VxRail nodes with either vSAN as the main storage or another type of storage, not necessarily vSAN. Okay, this can be SAN or a NAS, which means that this is not really a hyperconverged solution. So the reason for the existence of this kind of cluster is to give the customers the possibility to have the same VxRail experience from management point of view and get the benefits of the storage likes of NAS or SAN, FC-SAN or uh, dynamic nodes, as you can see, is a type of cluster that can use an existing um, Dell storage array, okay, as the main storage using FC. It can use an existing VxRail standard cluster running vSAN as the main storage. So here in this example, the cluster with vSAN is the storage cluster. The other two clusters are dynamic clusters with nodes providing compute resources only with no storage. This is possible using a technology called vSAN HCI mesh. We'll talk about that later in one of the upcoming modules. We can also use PowerFlex, which is one of our Dell EMC solutions as the main storage. That's an option. Or you can simply use IP storage, okay, and the likes of using the likes of NFS or eSCSI. All of that is supported. We also support NVMe over Fabric. These are different options available for dynamic nodes. The next type of cluster is called the stretched cluster. So as the name indicates, a stretched cluster is, as you can see, is a cluster stretched across two physical locations with the need of a third physical location to place the witness. Okay, so there will be something like I can't remember exactly, 6 or 8 slides about stretched clusters on day 3 or day 2. I'm not really sure. Uh, but anyway, we will talk a little bit about stretched clusters. It's going to be more interesting for those of you managing a stretched cluster. So this is completely different from a standard cluster. How the data is placed, failure tolerance, how the cluster will react to specific failure scenarios, etc. I will try to cover that as much as I can during the stretched